Tahniah! Secara langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda. Secara langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Okey, Assalamualaikum warahmatullahi wabarakatuh dan hai semua para guru, ibu bapa dan anak-anak pelajar sekalian. Selamat datang ke Pusat Tuisyen Akademi YouTuber bersama e-didik Malaysia dan Kelab Guru Malaysia. Bermula percuma, selamanya percuma. Sebelum kita mulakan kelas, marilah kita membaca ummul kitab Al-Fatihah. Untuk yang bukan Islam, bolehlah bertafakur mengikut kepercayaan masing-masing. Al-Fatihah. Amin amin ya rabbal alamin. Okey, apa khabar adik-adik semua? Cikgu harap semua berada dalam keadaan baik dan bersedia untuk meneruskan kelas kita pada hari ini. Cikgu percaya adik-adik semua dah tak sabar untuk meneruskan kelas kita kali ini. Jadi cikgu perkenalkan diri cikgu dahulu. Nama cikgu Nur Izian binti Saleh dari SMK Teluk Panlima Garang, Kuala Langat, Selangor. Boleh panggil cikgu Izian selaku moderator pada petang ini. Pada petang ini kita bersiaran secara langsung dari channel Cikgu P. Siapa yang belum subscribe, silalah tekan butang subscribe sebagai tanda sokongan kepada Mr. P. Nama sebenar beliau adalah P. Kok Hua dari Kolej Tingkatan 6 Tun Fatimah, Melaka. Kita akan mempelajari fizik tajuk 1.3 Keseimbangan daya iaitu ataupun forces in equilibrium ya. Okay, kelas ini akan berlangsung lebih kurang 1 jam. Selain itu kita juga ada Cikgu Kok Sime dari SMK Tinggi St. David Melaka selaku control host. Okey, jadi cikgu nak bagi makluman sikit tentang panitia fizik akan mula bercuti hari raya pada mulai 1 Mei. Jadi kita akan bersambung semula kelas pada 13 Mei untuk kelas fizik tingkatan 4 dan 15 Mei untuk fizik tingkatan 5. Okey, jadi sebelum kita teruskan kelas kita, ingin cikgu ingatkan semua pelajar dan penonton yang ingin menghantar komen untuk menggunakan bahasa yang sopan dan juga gambar profil yang bersesuaian untuk tontonan umum. Cikgu percaya semua yang hadir kelas pada petang ini merupakan pelajar-pelajar cemerlang dan mari kita tunjukkan disiplin yang terbaik. Okay, link e-sijil akan diberikan pada hujung siaran. Pastikan diisi dalam tempoh 30 minit selepas kelas tamat. Okay, link e-sijil hanya dapat diisi dengan email e-didik, MOE, Jawi dan juga MyGuru. Okay, selain itu, cikgu akan berikan kod untuk tebus ganjaran semasa kelas dijalankan. Jadi cikgu berikan kod yang pertama iaitu A2. Okay, A2. Okey, jadi sila fokus pada isi pelajaran yang akan disampaikan oleh Mr. P. InsyaAllah moga kelas kita pada petang ini dapat dimanfaatkan sepenuhnya oleh para pelajar. Okey, jika pelajar ada soalan ataupun tak faham boleh terus tanya di ruangan chat. Okey, jadi tanpa membuang masa lagi, saya serahkan kelas kita pada Mr. P. Silakan Mr. P.
Okey, so terima kasih Cikgu Izian. Okay, so sebelum mulakan kelas, okay, so cikgu buatlah sikit promosi, okay. So kelas tuition percuma fizik SPM untuk AYU setiap Jumaat, okay, pukul 3.30 petang kita ada kelas untuk tingkatan 4. Okay, so sekarang sudah masuk subtitle 21. So anda boleh lihat semula live teaching tersebut, okay, yang diajar oleh cikgu Selinda Nordin, okay, di channel dia. So untuk kelas tingkatan 5 diadakan pada Ahad pukul 2. So itulah jadual untuk kelas fizik SPM. So ini merupakan panitia fizik SPM Akademi YouTuber Malaysia. Petang ini bersama Cikgu P di sini ada Cikgu Izian dan juga Cikgu Kok. Okay, so terima kasih bersama saya pada petang ini. Okay, so saya Mr. P dari College Tingkatan 6 Tun Fatimah Melaka. So tajuk untuk hari ini adalah bab 1, daya dan gerakan 2. Subtopik yang akan dibincangkan hari ini adalah keseimbangan daya, forces in equilibrium. So there are 3 learning standards I will be going to teach in today's lesson. So the first will be explain the meanings of forces in equilibrium. Second, sketch a triangle of forces in equilibrium. And the last will be the most important parts, okay, for the subtopic of 1.3, which is the solve problem involving forces in equilibrium. Okay, so let us start our first learning standard, okay, is regarding the explain of the meanings of the forces in equilibrium. Okay, so what is the equilibrium of forces? So an object is said to be in equilibrium of forces when the forces acting on it produce a zero resultant force. Okay, so zero resultant force. So in subtopic 1.1, okay, I actually already introduced what is the resultant force. Okay, so today I am going to use the same example, which is the tug of war competition among the 2 students here. Okay, so there is 2 participants A and B. You can look at the situation 1. Okay, so the participants A and participants B both have the same magnitude of force, okay, but they are acting in opposite direction. Okay, so where the participant B pulling the rope, okay, to the right side, and the participant A is pull the rope to the left side. Okay, they are using the same magnitude of force. So what you can see that the indicator which is showing by the yellow flag, okay, is stare at the same place, or we know as stationary. Okay, so why? So this because uh, the resultant force, okay, for the force applied from the both participants is actually equal and in opposite direction. Okay, so we'll see the flag will be at stationary, and we can conclude that, okay, so the condition is in equilibrium. Okay, so while there are another 2 situations, in situation 2, okay, you can see the participant B, the force applied is less than the participant A. So you can see the movement of the flag, okay, moving to the side which applying the greater force, okay, which is at the right side, okay. You can see at the resultant force, which is showing at the right side. So in the situation 3, the participant A applied greater force compared to participant B, and the resultant force showing that, okay, so the force is moving at the left side. Okay, so here we can conclude that the resultant force will be same direction as the force with the larger magnitude. So in situation 2 and situation 3, they have the magnitude of resultant force, which is considered as unbalanced force condition. Okay, so we can conclude that in situation 1, the forces of the participant A and B is in equilibrium, while the situation 2 and situation 3, they are showing the magnitude of resultant force, okay, and they are in unbalanced forces. So 2 forces are in equilibrium if they are acting in opposite direction and with equal in magnitude. Okay, you can look at the situation 1. So here, I actually want to show you another examples, okay, of the 2 forces which are in equilibrium. So this one we are using the third Newton law, okay, where the action and reaction force, the magnitude will be the same, but adding in opposite direction. So here is the free body diagram of a book on the table. So you can see the W is the weight of the book, which is showing downward, and they are the same magnitude of reaction force, which is acting upward and have the same magnitude as weight of the book. So in the equilibrium condition, the resultant force is 0, which I already mentioned just now. So that means that W minus R will be equal to 0. So we can conclude that the weight and the R, okay, with normal reaction will be have same magnitude. And here is the free body diagram of a moving trailer. Okay, so again in forces in equilibrium, the resultant force will be also 0. So let us discuss about the component of vertical. Okay, this is the weight of the trailer. Okay, we can state as simple W, and the normal reaction will be R. So end up in the equilibrium condition, the weight will be equal to normal reaction. Okay, so in horizontal component, there are two forces applied, which is the same magnitude but in opposite direction. So here we have the pulling force acting at the right side, okay, which is same as the direction of motion, and they will be the same magnitude but opposite direction of reaction force here. That is the frictional force. So in equilibrium condition, the pulling force T, okay, will be same as the frictional force. So we can define that the equilibrium of forces can be as the statement, this statement. So resultant force act on an object is 0. Okay, so here you can look at the figure. So with the vertical component, the upward and downward forces have the same magnitude but in opposite direction. So 50 minus 50, you will get 0 resultant force. So they will be same for the horizontal component, the left and right side, okay, both will be have the same magnitude, which is 30. So 30 minus 30, final resultant force will be also 0. So we can conclude that the object is in equilibrium of forces condition. Okay, so two situations where equilibrium of forces occur. So here you will apply the Newton's second law of motion. So this one also one of the topic actually I discussed already in subtopic 1.1. So forces in equilibrium means that the resultant force will be 0. So according to the Newton's second law of motion, F equal to ma. All the matter has mass, so that means the A will be 0, so that the resultant force will be 0. So that means that the situation where the equilibrium forces occur, they must in 0 acceleration condition. Okay, so for 0 acceleration condition occur, okay, so there will be stationary state and will be uniform velocity. So this one we also already learned in section 2.1 syllabus form 4. Okay. Okay, so you can look at the figure here at stationary state. Okay, so there are two forces applied in the opposite direction but same magnitude. So W showing that there is the weight of the car, and R will be the normal reaction. So since this is in the stationary state, so the velocity will be 0 and the A will be 0. So as mentioned, when A is 0, the resultant force will be 0 also lah. Okay, so here we have only vertical component apply in this state. Okay, so finally you will get weight will be equal to normal reaction. Okay, so in moving with a uniform velocity condition, so there are four forces adding on the car. So in the vertical components, there are weight and normal reaction, just like the stationary state. There are two forces adding on a moving object which is moving in uniform velocity. Here will be T representing the thrust and the F1 representing as the resistance. Frictional force lah. Okay, so at the constant velocity condition, the acceleration will be 0. So in the vertical component, so R will be equal to W, and in the horizontal component, T will be equal to frictional force in equilibrium or forces condition. Okay, so let us go to our second learning standard, okay, which is regarding the sketch of triangle forces in equilibrium. Okay, so in 1.3.1, so I just discussed about the two forces in equilibrium condition. So here I will focus in the three forces in equilibrium. So vector diagram, okay, vector diagram or known as triangle of forces can be used when a body added by forces are in equilibrium. Okay, so the vector diagram normally will be used in the forces more than or equal to 3. Okay, and any numbers of forces are in equilibrium if they form a closed vector diagram. So what is the closed vector diagram? So will be this, like this figure lah. Okay, so the 3 line will be closed and become a triangle. Okay, so the direction of the arrow in the triangle is in the order around the triangle. So what means by in the order around the triangle? So if let's say you look at this figure, so the arrow showing in clockwise, okay, is in clockwise, okay, so that means is in the same order. So the arrow is actually can also be in anti-clockwise direction. So as long as there is in order, so we consider the three forces will be equilibrium. Okay. Okay, so according to the addition of vector force, so the vector force will be F1 plus F2 plus F3. So in the equilibrium condition, the sum of these three forces will be 0. Okay, if they are in equilibrium condition. Okay, so let us discuss the way how we get the forces, okay, in thermal, is in equilibrium by using the triangle of forces. So here we have an example. A length of weight W is pulled to one side by P, okay, by force of P, and make an angle of theta. The diagram shows the forces acting on the length. T is the tension of the rope. So that means here we have three forces acting on the length. So which is P, T, and W. Okay, so the W actually is the weight of the length, and P and T is the tension of the string. Okay, so the three forces T, F, and W acting on the length are in equilibrium. The resultant of the three forces are zero. So as mentioned, in equilibrium condition, resultant force will be zero. Okay, so here I would like to tell you how we can use the method of triangle of forces, okay, to get the parameter we needed, okay. So the magnitude of the three forces are represented by the length of the side of the triangle. They are drawn in sequence according to the direction of force. So that means they will be maybe in clockwise direction or in anti-clockwise if they are in equilibrium. Okay, so for the step one, you have to identify all the forces added. So here the question already given us the T, P, and W is the forces adding on the length. And the second, okay, so you have to draw a triangle. So here the vector started will be W and P. Okay, so W will be moved downward and the P will be moved at the right side. Okay, if let's say you put at the left side, at the right side on the top, so that means the two arrow is not in sequence already. So it will be wrong lah. So we have to move the P at the bottom here, so that the triangle will be in the sequence. Okay, so and then the last we have to complete the triangle. So we already draw the W at the downward and P at the right. So for sure that the third line, which is the hypotenuse of triangles, must be go up lah, like this. Okay, so we making of the angle of theta here. So this is the answer showing the three forces in equilibrium condition. Okay, so sketching triangle of forces here, I will discuss these three cases. So the first will be the stationary box on the inclined plane. Okay, so there are three forces you have to know, you have to identify. Okay, so the forces will be not stated, okay, in the question. So here we have the weight of the box showing as W, and the R will be normal reaction, and FR will be the frictional force. And the second case will be the frame hanging on the wall. So the forces added on the frame will be weight and also two string, okay, showing here. And the last cases will be the ship being towed by two tugboat with the constant velocity. So here mentioned constant velocity. So that means all the condition here is in the equilibrium condition. Okay. Okay, so the case one, okay, so a stationary box on an inclined plane. So draw triangle of forces for this condition, for this case lah. So as mentioned, you have to identify all the forces added. Here we have three forces adding on the box. So the first will be the weight. Second, here showing the normal reaction, and the frictional force will be moving, shown by the green arrow here. Okay, then the second step, you have to draw these three forces in the triangle, okay, and have to follow the sequence. Okay, so here, look at the answer. First, we can move the line of W first, okay, and you can see the frictional force will be put to here. So now the triangle is formed with the sequence. Here will be in clockwise direction. Okay, so this is the answer. Okay, make sure you label all the symbol to the vector and then show the direction angle here. Okay, so the second case will be a frame hanging on the wall. So first, also identify all forces added. Here will be weight and the tension of string. So the W showing the weight of the frame, and there are two tension string, which is showing by the green arrow and the blue arrow here. Okay, and then here is the angle for these two parts. Okay, so the string and the top edge of the frame here. Okay, so the next step, we have to draw the triangle. So, and also follow the sequence lah. So first, you can see we are moving all the vector here, okay, in the same direction lah. So here will be in anti-clockwise, okay, and then you have to label each vector and give the angle. Okay, so that means here total up will be 2 data. Okay, so this is the answer for second case. And the last case here will be a ship being towed by two tugboats with uniform velocity. So it's showing by the diagram here. So again, you can see in equilibrium condition, the object is moving with uniform velocity. So again, first we have to identify all forces added. So T showing as the tension of the cable, and the R, okay, tension of cable will be here, and R is water resistant, which is moving at the opposite direction of the motion of the object. Okay, and this is the angle. So here is theta 1 and here is theta 2. So both is actually equal number lah. Okay, again, step 2, we have to rearrange all the vector in triangle, which is also follow the sequence. Okay, so this is the water resistant, and this is the first tension of cable, and here we have the second tension of the cable. So you can see the triangle also moving in the sequence. Okay, here will be in anti-clockwise direction, and this angle will be moved to here, and the bottom angle will be moved to here. So this will be the answer, okay, for third case. Okay, so we have finished discussion about the triangle of forces. Okay, so now let us try together the checkpoint question number 1. Okay, so you may show your answer in chat room. Okay, if you are able to do. Okay, so here diagram 3 show a load with weight mg will be here. Okay, hang in equilibrium from 2 rope, PR here, and QR will be here. Okay, so which of the following diagram represent correct for forces added on the point? Okay, so since the question given in equilibrium condition, so that means the triangle must be in sequence lah. Okay, firstly, maybe you can check which ABCD here is in the sequence. So if let's say we see the A, so A is in sequence, right? All the arrow here will be moving in the anti-clockwise direction. So for the B, you can see also in sequence. So how about C? C also, and D. Okay, so that means here A, B, C, D all showing the same sequence. So we have to identify which is the correct one. Okay, so for the first one, the red arrow showing the weight, okay, showing the weight of the object, and the blue arrow showing the first tension of the rope of QR, and the green arrow showing the tension of the rope of PR here. So again, we have to rearrange the vector, okay, in the sequence. So here you can see the red arrow will be W, and then here the blue will be tension of QR, and the green color will be the tension for PR. So from the option here, the best answer will be B lah. Okay. Okay, so the next question. Diagram 6 show a basket of orchid hanging by the wall and the ceiling. Okay. So which diagram show the three forces T, W, and R adding on the basket in the orchard? Okay. So here again we have to identify all the forces added. The first will be here W, and the blue color arrow will be the tension for the rope of T, and the green arrow here will be the tension for rope R. Again, we have to rearrange all the vector in the sequence. Okay, so the red arrow will be W, which is in downward direction, and the blue color arrow will be T, and the green arrow will be R. So from here, we can see the answer will be A lah. Okay. Okay, so we go to our last learning standard. Okay, learning standard 3, which is the most important, okay, part for this subtopic. So solving problem involving forces in equilibrium. So for solving the problem involving forces in equilibrium, there are two methods here. So the method 1, we can using the triangle of forces. Okay, so how we draw the correct triangle in equilibrium condition? Just now, I already show you at section 1.3.2. Okay, after you draw the correct triangle of forces, okay, so you can use the trigonometry, sine rule, cosine rule, and Pythagoras theorem, okay, to get the answer we want. And second method, we're using the revolving method, okay, and then after you get the equation, you must able to solve the equation, okay, by using the simultaneous equation knowledge, okay, you have already learned at the PT3 mathematics. Okay, so let us discuss together the example 1. So the free body diagram show has three forces in equilibrium. Calculate the magnitude T1 and T2. So here, as mentioned, we need to identify the all forces added. So here we have the 150 Newton, which is the weight, and the T1 will be the tension of the string, okay, and T2 will be also tension of the string for the second rope lah. Okay, so the first, I will using the triangle of forces with trigonometry method to get the answer of T1 and T2. Okay, so again, the first we have to identify all the four forces added. Okay, as mentioned, there are W, weight, T will be tension in rope 1 here, and the T2 will be the tension in rope 2. Okay, so for the step 2, as mentioned just now, we have to form a triangle and all the vector must be follow the sequence. Okay, so here I will draw the 150 Newton vector first, followed by T2, and last will be T1. Okay, so here the first will be the 150 Newton, you can see is in the downward direction, and then second will be T2, which is in the right direction. Okay, so you can see they are in the sequence. So as mentioned, if let's say you put at the top side, both vector will be not in sequence already. So that means we need to draw our T2 as the bottom part here, and then we have to last will be close the triangle, which is the hypotenuse for this triangle. Okay, and show the symbol T1 for the tension of rope 1. So the angle here will be 30 lah. Okay, so after we get the triangle of forces, here we can get the value of T1 and T2 by using trigonometry. Okay, so the first we get the T1 will be here together with 150. So that means for this triangle, so T1 will be hypotenuse and 150 Newton vector here will be the adjacent. So adjacent over hypotenuse will be cos of angle of 30. So end up we get 173.21 Newton. And then we need to get the value of T2. This value here. Okay, so here we're using tangent. So that means we're using the opposite T2 together with adjacent 150. So we get 86.80 Newton. Or you can using sine 30 to get your T2 also. So for sine will be opposite T2 over hypotenuse. Okay, so we substitute our T1 value, which is 133 and 0.21 here. So you'll get the same answer. Okay, so the next method will be resolving method. Using the same question, okay, so identify all the forces added, which is W, T1 and T2. Okay, resolving forces horizontally and vertically. Okay, so here the W already in the vertical component, so you don't need to do any spreading for this vector. And the T2 also is already in the horizontal component, so you don't need to do any spreading for these two forces. But T1, there is not in vertical or horizontal component, so you need to split the T1 into two horizontal and vertical component. So here the angle 30 will be here. So if let's say we change the 30 to here, so that means the vertical component for T1 will become T1 cos 30, and the vertical component will be T1 sin 30. Okay, so for the horizontal component, T2 will be equal to T1 sin 30 because it's in equilibrium condition. And the vertical will be T1 cos 30 equal to W. So we get our two equations, and then we solve the equation, can be substitution or elimination. Okay, so here we get from our second formula, second equation, so which is the W equal to T1 cos 30. So question given that the W equal to 150 and cos 30 is equal to 0.86. So rearrange, we get the T1 will be 173.21, which is same answer with method 1. And then from the equation 1, okay, we substitute all the value, okay, and we get 86.60 Newton. So which is also same answer by using the method 1 also. So that means you can using method 1 or method 2 to solve the question. Okay, so I think we can take a break. First, Cikgu Izan.
Saya bagi, tadi Cikgu Tan Hui Ju kata great explanation, thanks for the easy understand steps shown. Okay, saya pun rasa senang lah, mudah nak faham leraian daya. Okay, jadi sebelum kita berhenti lihat, Cikgu bagi kod yang kedua. Kod yang kedua adalah 42. Okay, 42. Okay, adik-adik lepas ni kalau ada soalan boleh terus tanya di ruangan chat. Okay, kita rehat dulu.
Tuisyen online percuma. Tuisyen online percuma. Layari www.academyyoutuber bagi mengikuti tuisyen online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi YouTuber. Rujuk jadual di laman sesawang www.academyyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuisyen online percuma mestilah Akademi YouTuber.
Okey, kembali kita. Okey, jadi kita teruskan dengan soalan yang seterusnya. Okey, dipersilakan Mr. P.
Okay, so thank you Cikgu Izian. Okay, so thank you juga kepada yang berikan komen kepada saya. Okay, Cikgu Tong dan juga ada Chain di room chat. Okay, so sekarang kita pergi ke example kedua. Okay, so for example 2, I also will showing you the 2 different method, okay, to solve the same question. So diagram show 3 forces are in equilibrium. Okay, so here we have the W, weight, F1 and F2 will be the respective tension for the string. Okay, and the angle here is 70 showing at the figure here already. So the weight of the object is 200 given by the question. Okay, so draw a triangle to show the equilibrium of the forces for the 3 forces and calculate the force of F1 and F2. So the question asking you firstly to draw the triangle of forces, okay, and then you need to find out the value of F1 and F2. Okay, so the first, I will show you the triangle of forces method first. Okay. Okay, so here you can see the firstly we have to draw the triangle. So we started with the W, which is showing at the downward arrow. Okay, and then the second, okay, will be the F1. Okay, again, we need to put at the correct direction, which is showing the triangle will be in the sequence. Okay, show the symbol for the vector, and then the last will be F2 lah. Okay, you can see in this triangle, all the 3 vector is moving in the same sequence. Okay, so the 70 will be here. Okay, this is the angle here. And if I say you extend the line here, you can see this angle 70 will be at here. Okay, here we have the vertical opposite angle for this line and this line. So we get this angle will be also 70. Okay, so one triangle will be sum of the triangle equal to 180. So that means here will be 40 degrees. So this is the answer for the triangle, which is showing these 3 vector is in the equilibrium condition. Okay, so here we can start to solve the problem, okay, we want to get F1 and F2. Okay, so as mentioned here, we are using triangle of force, but now I will show you how to apply the sign rule for this question. Okay, so to apply the sign rule, you have to get two pair of the angle together with the vector. So here we need to find the value of F1. So the F1 will be paired with the opposite angle here, which is the 70. Okay, and then we're using the 200 Newton vector here, and the opposite angle here will be the 40. Okay, so these two pair value we will use to solve the question, okay, and get the F1 by using the sign rule. Okay, so you just substitute F1 over sine 70, which is the first pair, the vector together with the angle, equal to the second pair. Here will be the vector of 200 together with the angle, which is 40 degree. Okay, so we arrange, we get the F1 will be this value. Okay, make sure that your answer have correct unit together with minimum 2 decimal places. Okay. Okay, so now we go to solve the value of F2. Okay, so the F2 here will be together with the opposite angle, which is 70. This is the first pair. Another pair, we're using the same 200 vector together with 40 lah. Okay, again, the first pair will be the vector F2 divided by sine 70, and the second pair here will be 200 divided by sine 40. We arrange, we get the value will be 292.38. So the both vector F1 and F2 have the same magnitude. Okay, so now with the same question, I will try to solve the question by using the second method, okay, with solution method. Okay, so firstly, identify all the forces added, and then resolving forces horizontally and vertically. So again, you can see the W is already showing downward and at the vertically component. So we don't need to split, okay, the vector of W. Okay, for the F1, there is not in the horizontal or vertical component. So we need to split F1, okay, to become F1 cos 70 degree, okay, for the component of vertical, and the horizontal will be F1 sine 70. Okay, there is the same method, okay, to splitting the F2. So the horizontal component for the F2 will be F2 sine 70, and the vertical will be F2 cos 70. Okay, so from here we get our horizontal component, okay, which is these two vector. Okay, F2 sine 70 degree will be equal to F1 sine 70 degree. So this is the first equation we get. And for the vertical component, okay, which will be this. So the downward, we have only one vector here, which is W. And the upward vector, we have two, which is the F2 cos 70 together with the F1 cos 70. So we get our second equation will be like this. Okay, last we have to solve, okay, the both equation, okay, and I will using the substitution method here. Okay, so from the first equation, okay, we get the relationship here will be F2 equal to F1, and from the second equation, which is from here, we substitute the equation 3 to 2. So that means we substitute our F2 become F1. So F1 cos 70 degree plus F1 cos 70 become 2 F1 cos 70. So we rearrange F1, we get our value will be 292.38. The F2 is equal to F1, so we get the same value. So by using the second method, we also able to get the same result, okay, even though we're using a different method here. Okay, so example 3, I just showing one of the method to solve the question. Okay, the diagram show a box, okay, with mass of 5 kg. Okay, 5 kg is at rest on inclined plane. So rest, that means they will be in equilibrium condition, and the angle making here will be 15 degrees with horizontal. So the question asks you to find the frictional force and the normal adding on the box. Okay, so to do this question, you have to recall the section of 1.2, which was already taught by Cikgu Hasita last week. Okay, but here we only discuss the equilibrium condition, which is in rest or uniform velocity condition. Okay, so you can look at the box here is in the resting or stationary state. Okay, so firstly, we identified 3 forces adding on the box, which is the W, weight of the box, R will be normal reaction, and the FR will be the frictional force. Okay, and the angle theta here will be at here. So again, here we have to split the W, okay, to perpendicularly to the inclined plane here. Okay, so we get mg cos theta, and the parallel to the inclined plane, we will get mg sin theta here. Okay, so first we observe the perpendicular vector to the inclined plane forces here. So we have 2 forces adding perpendicularly to the inclined plane. So which is the mg cos theta and r. Okay, so r minus mg cos theta will be 0 because this is a rest condition, which is equilibrium, and the resultant force will be 0. Okay, so we arrange, we get r equal to mg cos theta. Okay, and then the next will be parallelly vector to inclined plane. So here we have the frictional force, okay, and the mg sin theta here. So again, here 0 showing that the condition is in equilibrium. So we arrange, we get the frictional force will be equal to mg sin theta. Okay, then we go back to our question. Firstly, as mentioned, we need to identify all the forces applied. Okay, here we have weight equal to mg, normal reaction, and frictional force. Okay, so we splitting the vector of W to become mg cos 15, because the 15 angle will be here. And together with the mg sin 15, 15 degree, which is the parallel vector to inclined plane here. Okay, so for the parallel vector, we have our frictional force together with mg sin 15 here. So we just substitute all the value. The phi is given by question, which is 5, and g is equal to 9.81, okay, which will be given by the question also. And we just press our calculator, we get 12.70 Newton. So for the perpendicular to inclined plane, we have our normal, which the question asks about the answer, and the downward part will be the mg cos 15. So we just substitute all the value, we get our answer for the normal reaction here will be 47.38 Newton. Okay? Okay, so we have go to our third question of checkpoint 1.3. Okay, so let us do together. So 5 Newton load is hang at the rope. Okay, will be this. Between two walls. So here will be two walls here. So determine the force of T and F. Okay, so firstly, we identified three forces W, T, and F already. Okay, so here I show you the method to solve this question by using the triangle of forces. Okay, so this will be three vector adding at the load here. Okay, again, we have to rearrange all the vector, okay, so that they will be in the same sequence here. Okay, here we can using the theorem Pythagoras actually. Okay, so the question asks us to find the F. So F will be using here is tangent 30. So tangent 30, that means here we're using adjacent F over, opposite F over adjacent. And then we rearrange, you get the value will be 2.88 Newton. And then the T here are using cos theta at cos 30 degrees. So cos will be adjacent over hypotenuse. So adjacent will be 5, hypotenuse will be T. So we arrange, then we press calculator, we get our value for T will be 5.77 Newton. Okay. Okay, so the next question for here is pulley together with the load here. Okay, so load of 3 Newton, 4 Newton, and W are hang with a non-extend string through 2 smooth pulleys. The 3 forces are in equilibrium. Calculate the value of W. Okay, so first step, you have to identify all the forces adding on the load of W here. Okay, we have the W for the arrow showing downward, and the red arrow here showing the first string, okay, tension, and the green arrow here showing the second tension of the string here. Okay, so that means here I will using the triangle forces to solve this question. So again, okay, we have to arrange the triangle, okay, in the same sequence here. Okay, so you can see all the arrow is in sequence already. So this is a right angle triangle. So the W is actually the hypotenuse for the triangle. Okay, so the question asks us to find out the value of W. So using the theorem Pythagoras, okay, so we square root 3 and 3 squared 2 plus 4 square we get W will be equal to 5. Okay, so we go to our last question. Okay, so this is Cron SPN question actually for the section A paper 2. Okay, so diagram 1.1 and 1.2 shows 2 identical mirror which are hang on a wall using string. So we have string here T1 and T2. Okay, this is the tension for the string 1, and we have the T2 which is the tension for the second string here. Okay, both have the same length. Okay, so the 2 mirror are in equilibrium state. Each mirror has a mass of 3 kg. Each string can withstand maximum force of 20 Newton. So that means the string will be broken if the tension is greater than 20 Newton. Okay, so T1 and T2 are the tension of the string that act on the mirror in diagram 1.1 and 1.2 respectively. Okay, so determine the value T1 and T2. Okay, so here the question not ask you to draw any triangle, so you can choose whether you want to use the triangle of forces or you can use the resolution method. Okay, so here I will show you the resolution method. Okay, so for resolution method, again, we need to identify all the vector, all the forces adding at this point here. Okay, so the W will be the weight of the frame. Okay, and then here we have the first tension of string, and here we have the second tension of the string. Okay, here we have the angle of 60. So that means here will be also 60. Okay, so I will choose vertical component because the question already give us the value of mass of the frame already, of the mirror already. So W is equal to mg. Okay, G will be the mass of the mirror and G will be equal to 9.81. Okay. Okay, so look at the answer here. So component, vertical component, given that the M is equal to 3 and G equal to 9.81. Okay, so here W will be equal to 2 times T1 sine 30. Okay, because we have the two resolution for the first string here, we get T1 sine theta. The angle here will be 60 lah. So for second string, we'll get another vertical component, which is also T1 sine 60. Okay, so that means we get 2 T1 sine 60 here. Okay, so we substitute the value given and we rearrange. We get the tension 1 is equal to 16.99. Okay, so we solve the first value of T1. So how about the T2? So again, we have to identify all the forces added, okay, at this point. So we have the W, weight of the mirror, and we have the string tension 1, okay, and we have the tension of string 2 here. Again, we get the angle here will be 30. So when we solve T1, this T2 to the vertical part, here will be T2 sine 30, okay, because the 30 will be here. And then we solve, okay, we split this T2, our second string of T2 here. We will get another T2 sine 30. Okay, so end up we also get 2 T2 sine 30 here. Okay, one come from this string, another T2 sine 30 will be come from the second string here. Okay, so we rearrange again the position. We get our T2 is equal to 29.40 Newton. So from here, we can see that when the angle for this position, which is between the string and the top edge of the frame, when the angle is greater, the tension of the string will be reduced. Okay, so that means we'll be able to use for longer time. Okay, so this will be the next question. Based on the answer above, which is more suitable method to hang the mirror? Give one reason for your answer. So here we 2 mark. One will be your choice, which is diagram 1.1 or 1.2. So that means you want to use the bigger angle or you want to use the smaller angle. Okay, as for the answer from the A, we get our T1 is equal to 16.99, which is smaller. And we get the T2, tension is equal to 29.40 Newton. And the question also mentioned that the string is only able to withstand the maximum force, which is 20 Newton. So from here you can see with the bigger angle, we will get a smaller tension, which is here T1 is smaller than 20 Newton. Okay, so that means the string of T1 is still managed, okay, to hang the mirror with 3 kg. However, when we decrease the angle, okay, between the string to the top edge, okay, of the frame, which is 30 degrees here, the tension is increased and greater than the value of 20. So that means here the string for diagram 1.2 will be broken. Okay, although diagram 1.1 and 1.2 both is actually holding or hanging the same mass of the mirror. So that means here we have to choose method of 1.1. Why? As mentioned, because the T1 had a smaller value. So the tension of the string T1 is smaller, so that the string will not easily broken. So that means the angle, okay, angle here, this angle here, play an important role, okay, to affect the magnitude of the tension. So we have to choose bigger angle so that we can reduce the tension and the string may not be broken. Okay, so that's all for my sharing today. So I pass back to Cikgu Izian.
Okey, terima kasih Mr. P. Okey, saya rasa sangat bermanfaatlah kelas hari ini, bukan saja untuk student tapi untuk saya sebagai guru, sebab slide yang cikgu Mr. P beri itu pun mudah difahami dan senanglah, betul lah cikgu Tang cakap tadi, memang mudah. Okey. Jadi sebelum kita tutup kelas hari ini, jadi cikgu nak ucapkan terima kasih pada Mr. P. Kita dah selesai kelas pada petang ini. Dan cikgu juga nak ucapkan tahniah kepada sesiapa yang berada bersama kita pada petang ini dari awal sehingga ke saat ini. Jadi cikgu minta sebelum kita tamatkan sesi siaran langsung, bolehlah tekan butang subscribe dan aktifkan ikon loceng sebagai sokongan kepada Mr. P. Dan jika anda suka, boleh klik like dan share kepada rakan-rakan media sosial untuk sebarkan ilmu dan beroleh kebaikan di atas perkongsian tersebut. Okey, jadi cikgu akan berikan kod yang terakhir iaitu 556. Okey. Okey, jadi link sijil boleh didapatkan pada bahagian ruangan chat Okey, cikgu rasa dah ada kan? Okey, so boleh pastikan isi dalam masa setengah jam selepas live ini. Boleh login guna email e-didik, MOE, MyGuru ataupun MyJawi. Okay, jadi cikgu sebelum tamatkan kelas pada petang ini, cikgu jemput cikgu Kok untuk berikan sepatah dua kata. Silakan.
Okey, selamat petang kepada semua pelajar lah. Harap-harap pelajar boleh promotkan dengan akademi YouTube kepada ramai pelajar lagi. Mungkin yang ini ialah pelajar yang baru, mungkin dia naik form 3 pergi form 4. Dia masih tak tahu ada cuma untuk tuition ni daripada AYU. So pelajar-pelajar lama boleh haraplah boleh promote dan dengan tuition percuma ni kepada rakan-rakan supaya mereka boleh mendapat ilmu secara percuma. Okay, so yang fizik ni bukan subjek yang senang. So kalau pergi tuition kena bayar lebih. So belajar-belajar boleh setiap Jumaat dan juga Ahad mengikutkan kami punya tuition online fizik. So belajar boleh dapat ilmu dan juga soalan-soalan yang seperti dalam peperiksaan SPM kami akan bincang dalam channel ini. So terima kasih kepada pelajar yang boleh promote ni lah. Okay, terima kasih.
Okay, terima kasih Cikgu Kok. Okay, Jadi cikgu nak ucapkan terima kasih, berbanyak-banyak terima kasih kepada semua penyokong Akademi YouTuber untuk sesi 2022 ni. Betul cikgu Kok kata tadi, tolong ajak rakan-rakan, jangan manfaatkan apa yang telah diberikan oleh cikgu-cikgu di seluruh Malaysia sebab fizik ni memang bukan mudah dan kita perlukan kelas tambahan lah. Jadi ini kelas tambahan percuma kepada anda. Jadi doakan kami semua terus kuat dan bersemangat untuk membantu anda semua dalam membangunkan pendidikan Malaysia. Okey, jadi itu saja untuk hari ini. Dan cikgu ingatkan semula panitia kita akan start bercuti raya pada 1 Mei ini dan akan sambung semula pada 13 Mei untuk tingkatan 4 dan 15 Mei untuk kelas tingkatan 5. Okey, so itu saja untuk hari ini. Assalamualaikum. Bye.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata gancaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus gancaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.